Welcome to this video tutorial on test-driven development, or TDD as it is often called. In test-driven development we write our tests first. We think about 3 steps. Step 1. Write a failing test. Step 2. Write the minimum amount of code to make the test pass. Step 3. Refactor the code. Does that sound good? Great, but let us expand the 3 steps concept a little more. We write our first test and then run the test code. Yes, we know the test will fail, but we must run the test, and we will see that now the testing framework will guide us with the next step. This is exactly what we want. We develop one step at a time. Now we write the minimum amount of code required to make the test pass, remembering to run the test at each stage, so that we get assistance from the testing framework. We will now have a test that passes. Now that we have a passing test, we can refactor our code and ensure we have clean code. Remember, run the test again to ensure the code has not been broken. So, why is refactoring the code so important? Well, firstly, refactoring can be done after each test or after several tests. Secondly, it's an important practice, because it ensures our code gets easier to read and maintain, while still passing all of the previously written tests. Third, refactoring can mean many things, but as developers we would refactor to change a piece of code without changing its functionality, for example rename a method, or to split a large method into multiple smaller method calls. Now we will look at a test based on a user story. The user story is, as a user, I want to input 2 numbers, so that I can have the sum of the 2 numbers returned. So, what will we call the class that holds the code? Let's say we call it myArithmetic. Now, what will we call the method that will exist in the class? Let's say we call it sum. What type of method will it be? Is it a void method, a value method, a parameter method? Well, it will be a parameter method, as it accepts 2 values as its parameters. And, it will be a value method, as it will return a value, the sum of the 2 parameter values. What 2 numbers are we going to use to test the method? Let's say we use 10 and 20. What is the number we expect back? Well, we should be expecting the total to come back as 30. So we are saying, if I pass 10 and 20 to the method called sum, in the class called myArithmetic, I expect 30 to be returned. Now we have a full specification for our code, so we can start to write the test using our testing framework and integrated development environment, which will help us build the class and method. So, our code might contain open brackets, 30, which is the expected value, comma, myArithmetic, which is the name of the class instance, dot, then sum followed by open and close brackets, which is the call to the method, and in between these brackets we have the 2 values 10 and 20, and finally we close the first opening brackets. And then we use the JUnit method to assert that the returned value is equal to the expected value. We will use the assert class, and from this class we will use the method called equals. Therefore, we will have the statement assert.equals. That's the theory. Now let's put the theory into practice by coding using the test-driven development approach. Watch the next video to code a test-driven development-based application.